Hey guys, and welcome to section 4 of chapter 7 of the pre-algebra program, where we're going to be solving inequalities using addition and subtraction. So we're going to take these inequalities that we were introduced to this past section, so yesterday, and we're going to add in something that should look very familiar. So it's the idea of solving these things like we would in a one-step equation, except we're using inequalities. And this will be a really great practice and review for you of being able to do this with all real numbers because we're using positive and negative integers. We're also going to be using some decimals in a few of the problems and even some fractions. So you'll get some good review here of those steps. Okay, so without further ado, let's go ahead and jump in to some examples. So if I have something like m plus 9 is less than 14, we're going to go about this exactly the way that we did with the one-step equations, where we isolated the variable and then we have to either add or subtract away from it. So right now it's being added to 9, so in order to undo that, I'm going to take away 9, just like I did with the equal sign. I'm going to treat the inequality sign like an equal sign and take away 9 from both sides. So I'm going to get m is less than, and then do 14 minus 9 is 5. Okay, now a couple of the questions are going to ask you to solve for these inequalities. Some of them are going to ask you to check your solution, and some of them are going to ask you to graph. So I'm just going to go ahead and do all of that for your examples just to get you comfortable with it. Okay, so they're telling us that our solution set here then has to be less than 5. So I'm going to pick a number less than 5, and I'm going to check to see if it's true. If it's true, then I know my answer is right, and I can move on. So I'm going to let m equal 0. If I can ever use 0, I do. It's super easy to work with, so it's always my go-to number to check. So my solution set is m less than 5. So any number less than 5 will work in our solution set. So that's why I picked 0. And I'm going to substitute 0 in for m. So instead of m, I'm going to write 0 plus 9 less than 14. Then I'm going to go ahead and add and ask myself, is 9 less than 14? And of course, the answer is yes. So my check is good. I've solved it. Everything looks great. Now all we have to do is graph this thing. So remember our rules from yesterday. You're going to go ahead and do your number line. Again, if you want to do a really nice one, that would be great. And then you're going to find your number. In this case, it's 5. Notice it was m less than 5, just to keep it on the screen here. I don't have an equal to sign, so I'm going to have an open circle. And I want all of the values less than that. So I'm going to go left. Hopefully you had a couple days with that earlier this week. You should be feeling relatively comfortable. Okay, let's do another one. What if I had k plus negative 5 is greater than negative 12? All right, look at those integers here, positive and negative. Remember we learned that a positive times a negative is a negative. So I could rewrite this as k minus 5. Now I can isolate that variable and recognize it's being subtracted by 5. So I need to add 5 to both sides of the inequality. And negative 12 plus 5 is negative 7. If you're still feeling a little bit uncertain about these positive and negative integers, make sure you have a large number line somewhere close or draw one at the top of your page so that you could find negative 12 and add 5 and find that you're at negative 7. Okay, so now we want to go ahead and do a check. So I need a value, k, that's greater than negative 7. Guess what? 0 is greater than negative 7. So I'm going to pick that guy. So I'm going to plug that in for K and see if this is true. Again, remember I have my positive times a negative, which is a negative. And 0 minus 5 is negative 5. And then we have to ask ourselves, negative 5, is negative 5 greater than negative 12? And again, be very careful when answering that question. I know it looks like maybe negative 12 is bigger, but when we're talking about negative numbers, this negative 12 is all the way down here. And so negative 5 is greater than that. And I know that we're good. Okay, so then to graph this guy, we're at negative 7. Notice there's no equal to sign. So I need an open circle, and I want all of the values bigger than negative 7, which means we're going to go to the right here. So open circle and everybody pointing to the right. All right, please pause the video if it's going too fast. I'm going to try to get through a couple more examples here without boring you too much. I'm sure you guys are loving the videos. They're your favorite part of the day. Just kidding. Okay, so let's go ahead and solve this guy. Remember what two negatives did for us? Remember that when we had two negatives together, a negative times a negative actually became a positive. And so that can change to plus 6. Then in order for me to solve this, I'm going to subtract 6 from both sides. And now I'm going to take 20 minus 6, which is 14. Less than r. Now this one is a little bit different because now the number is on the left-hand side and the letter is on the right. So we always read the inequality with respect to the variable, which means that this is actually r greater than 14. Or I could reverse this for you so it looks a little bit like the other ones, where I'm going to put r on the left-hand side and 14 on the right, but I have to switch my inequality. Notice my inequality is eating, my Pac-Man sign is like eating my r. So he better be eating your r over here if you want to go ahead and flip the signs so it's a little bit easier to read. So you're going to get some practice with this. I want you to make sure that you're always reading the answer with respect to the variable. So what's happening is the Pac-Man sign eating the variable greater than or facing away from it and being less than. Okay, so now my actual solution set is r greater than 14. So when I check, now I don't get to use 0 this time. Let's go ahead and use 20. So now I have 20 less than 20 minus a minus 6. Remember, those two negatives together go positive. And is 20 less than 26? Yes, of course it is. Okay, and then for my number line, I'm going to graph this baby all the way down here at 14. He's still an open circle. And I want all of the values greater than 14. Notice we picked 20, right? So that should help you out too if you're still struggling with that a little bit. So our arrow has to point right because our check was r equal to 20, and that was true. So our arrow has to include the value of 20 in our number line. Okay, I'm going to do one more example for you like this, and I'm going to be using some fractions, which will make you super happy. I know everybody loves fractions. Not really. All right, 2/3 less than or equal to a minus 5/6. And I just want to do a problem like this quickly to review what it means to add and subtract fractions. So we isolate our a, and it's being subtracted by 5/6, so that means I'm going to have to add 5/6 to both sides. And keep that a over there. Okay, now I have fractions with different denominators. I need a common denominator in order to be able to add them. So I look at 3 and I look at 6, and of course the least common multiple is 6. So I can change 3 to 6 by multiplying top and bottom by 2. And then I'm going to get a new fraction, the 4 over 6. And I'm going to add that to 5 over 6. And now that I have the same denominator, I can just add the top. So I get 9, 6, which is less than or equal to a. And we always want to reduce. So you can divide top and bottom by 3 and get 3 over 2 is less than or equal to a. Now I have the same issue like I had in the previous problem. My a is over here on the right-hand side. My Pac-Man sign, or my inequality sign, is eating the a. So if I want to switch these, I can move a to the other side, but the inequality better still be eating him. So you got to flip that guy too. All right, and then we need a value in order to check that's greater than 3/2. Well, how about 2? I like to keep things small if I can. Seems like maybe that would be easier to check. Okay, so now 2/3 is less than or equal to 2 minus 5/6. Now, I want this fraction or integer to become a fraction of like denominators. So I can multiply top and bottom by 6 and get 12 over 6 minus 5 over 6. And then I would get 7, 6. And I want to know if that's greater than 2/3. Well, 2/3 is less than 1. And 7 over 6 is greater than 1. So just by that fact alone, I know that it has to be true. So I know that a is going to be greater than or equal to 3/2. And then we just need to graph that. Remember that 3/2 is like 1.5, so you're going to be right in the middle here. And we have a closed circle because of the equal to sign underneath the inequality. And I want all the values greater than that, which means I want it going to the right. Okay, I feel like maybe I went through that a little bit fast. Please take your time. Go back through, pause when you need to, catch up on your notes, read through the examples in your book, and begin your assignment.